So Surya,
Yes.
do you know the last? Do you know the last crazy news?
No, tell me.
I just discovered that on the other side of the open space, right next
Uh-huh.
here, there is another team rebuilding the same component as the one we just built for the
Okay.
past 3 months.
The incredible one.
Yeah,
The incredible
this huge one.
Yeah, okay. You know what? It doesn't really matter. There's a new head of digital marketing, and she decided we had to do everything again. All the websites, all the applications.
Seriously?
We have to change all the site. Yeah. So.
On each website, we're gonna have to change once again the layout, the design, and all.
Yep. And every component we
But
copy
we just
pasted
did it 2 years
everywhere.
ago. Oh my
Yeah,
goodness.
I know. I guess it would have been better if we had a way to share our code from all the
Yeah,
applications.
but we wanted
but
to.
yeah,
Yeah, but it was not priority.
no, never.
So, I guess you might have already heard this kind of conversation before, and
Now that you have it all.
yeah. So our plan is to show you how to avoid those kind of conversation in the future.
So let us introduce ourselves. My name is Surya Ambrose. I'm an architect developer at Theodo.
I'm Xavier Lefèvre. I'm a VP of Engineering of Theodo. So Theodo, our company, is a development agency. So quite classical. We develop software, mainly web applications for companies, any size of companies. And for a particular mission for a big bank, we met this exact situation.
And more specifically, what happened is that there was one project, which was a very big project with basically a very big component, a super hard component. We spent months working on it just to discover that there was another project that made the same component just above. So this was a bit sad. And at that moment, we thought, maybe it would have been interesting to share this code, this incredible component between the two projects. But now that the projects are done, what's the point? The websites are already there, so why should we share it? But with time, we actually made this component 6 times with 6 different teams in 6 different projects. And at this point, it became a bit easier. We could tell our clients, okay, we did it 6 times. Nothing can prove that there will be a 7th. And at least with those 6 times, if there is a bug we want to fix, we have to fix it 6 times. So it might be interesting to group all this and to share the code. So this is how we were able to actually take time to create a library with all our components that we could share across the project. This was something that was quite hard because we were application developers and not library developers. We didn't know how to do it. So we had to take time to learn, to improve. We met a ton of problems, as you can guess. And if you're a bit like us, maybe this is something that you might want to do in your own companies. And this is what we are going to explain to you today, what we did, the difficulties we met, and how we tried to tackle them. So before we start, a few information. First, here we are about to talk about how to share components and not how to make them. We won't tell you how to make the perfect component that is the top of its top component of all time. We just want to share it. And so we're going to talk about configuration, structure, tools, but not the component itself. And because we're not going to talk about the component itself, our project was a React project, so you might see code examples that will be React, but everything we're going to explain can be translated to Vue, Angular, or any other front-end project. And what we're going to start with is this kind of project where you have an app and components somewhere in a folder, and this is the folder we are trying to share today. So if you have an application like this, the first thing you want to do is to distribute your components and distribute your code. Because when you deploy your application, what you are used to do is to bundle it, probably with Webpack or another bundler, and then deploy it to a server that will serve it as static files, so HTML, CSS, JavaScript. But to distribute this code as a library, this is a bit different, and there are a few things that you will need to change. I guess you all know this file, a package.json, the one that describes basically your project. You know it probably because this is where you set all the dependencies of your project and the scripts you want to use. We will need to modify it a bit. So the first thing I would like you to add, I advise you to add, is a bit of informative data. So what is in your package, the description, who write the package, so you, and the license. So these information, we'll see it afterwards, are hints for your users to know when they can use it, in which circumstances, and well, if they want to use it actually. So these are hints. And the last thing, I removed the private true property, which is something that is here to prevent an accidental publish. And since we will want to publish in the end, so I removed it. You will also have to change a bit your build process. So I talked about Webpack, about how you need to bundle your application. If you have an optimized bundling, this is the kind of thing you might have. Different chunks, so your code is splitted in different chunks with hash so that you can optimize the browser cache and so on. This is not something we want. We want to get rid of any Webpack optimization because people will not actually use this file with this changing name and so on. So it's easier if you give them one file that has everything and then let them handle it. And the second thing you have to change is this thing. So usually your classical bundling will create code that is optimized for your browsers, but code for browsers is not super nice for bundlers. So you can change Webpack configuration to create your code as a UMD, which means Universal Module Definition. And this kind of code can be read by browsers and by all bundlers. So by changing this, you're sure that your code can be read by anything. And finally, one of the last things you have to do is to add this property in your package.json. This is to specify the entry point of your package. This means that when someone will actually require your package, this is where they'll get. So they will receive this file and all the code that is in it, which is your components. Now you have your package. You can just push it. And that's actually quite simple. You just have to log into NPM registry. If you don't have an account, log into it, we'll actually create one. Easy. And then publish. And that's all you have to do to get it on NPM. If you have concerns about pushing public packages, you can either use a private NPM account, that's okay, or you can use, and that's what we did, an alternative to NPM. So there are a lot of open sources NPM registry, alternative NPM registry. So we use that one, Verdaccio, for a bit more than a year now, and it's actually working pretty fine. And what is nice with all those tools is that you can actually use them on premises. You can install this on a server somewhere in your company, and you know that your components will never get out. So especially in the context of a bank, it's actually pretty interesting.
Cool. So second step, we're capable of building a library. We're capable of sharing it with other developers, but we need to showcase it. The people need to be able to understand what's inside of those libraries. Product owners or designers need to be able to see what's inside as well. We need to find a solution for that. So most of the biggest libraries have documentations, pretty extensive documentation about how to use their library. This documentation takes quite some time, so we had to find an intermediate way of showcasing our own components. So that's why we use Storybook. You might have heard about Storybook at the previous talk, and on your side as well. So Storybook, we used it. Storybook is meant first to, it helps you to easily display simple components isolated from anything, any context, any business, any website. That's here that you will show your any size of components. We used it as well because it's extremely convenient to develop. We developed, as developers, new components directly inside of Storybook, and then you just have to push it and see it live. It's just a basic static website. It just looks like that. On the left side, you have the list of components, and in the middle, the components you want to display. So it's pretty simple. And how do you add it? At the same time, it's as well extremely simple. You just have to put your component, your component, inside of a function, a story function, and then it's going to be displayed like this again. So this is one of our components this time, and you can go around all your components. And of course, if you have like 100 components to display inside of your documentation, it's as simple as those few lines of code. Then, if you want to go a little bit further, because the component is not just static, of course, it's dynamic. You want to be able to let the users play around with the properties. So you have these little helpers that are called knobs. You put it inside of each properties, and it's going to have an impact on the interface itself. At the bottom, you're going to be able to see that those little inputs as properties to play with and to see the behavior they have on the component itself. Further, you can also display the behavior of callbacks of your components, because when someone clicks on the component, you may want something to happen. So there is another plugin from Storybook that's called Actions. You at the same, once again, put it inside of the props, and it's going to do that. At the bottom, in the second tab, you're going to be able to see all the information of the click, the properties, and the information of the function. Pretty convenient. And auto-documentation. To go even further, and we didn't even have the time to test it yet because I think it got out like 1 month ago, the Storybook team released a new big feature which allows you to mix Markdown with your dynamic components, with your stories. So you're capable of illustrating dynamic components in the middle of with advanced documentation regarding your business or anything you want to share, which becomes quite sexy and quite automatic once again at the same time. So we're happy with it. And this, we will be happy the day we try it.
So now you have a library. You have shared your components and they're accessible. You have a store where you can display them. But remember what we said earlier. There is many different projects, many different teams. So you're sharing your components to them, but they might also create their components and you might want to use them. So what you will want to do now is to encourage them to come into your library and to add stuff to your library. You want them to contribute. And to do this, you have 3 major steps. The first one is to make sure that your contribution process is very clear. In any open source project, there is at least a bit of a documentation saying you can contribute, and this is how you should do it. This is the only way for someone to know that contributions are welcome. And for us, we did a very big piece of documentation, very detailed, because bringing someone into contribution is like getting a child to the school for the first day. You have to make him feel safe and secure and that you'll be here at the end of the day to get him back. So here it's basically the same. They don't know anything about your library and they don't know anything about what you do there. So you have to help them as much as you can to get in and assure them it's going to be fine. The second thing is that you have to make your quality standard very clear, like the test coverage you want, the commit message, what kind of commit message you want, which structure. You can use the documentation again, or you can also use the pull request templates. All those hints are very easy for contributors to get. And why do you need all this? Because your library is going to be used in different applications. So your standards must not be high, they must be like super high, because everything that is low quality will have a huge impact not only on you, but on every user you have. So you cannot underestimate this, and you have to make sure that your contributors know about it, because if they don't, you will have to reject their pull request once, twice, 3 or 4 times, and then they will just go out, and you lose something interesting. And finally, you will have to answer questions all the time, because you will have holes in the documentation, something which won't be working. People will come to you, ask questions, and if you're not there to answer, they will just leave. So you have to be always there to encourage them to keep going, and it's fine to ask questions because you're there as a security net. And all those 3 things, that's actually everything that an open source core team does. So you have to be like an open source core team and be there to help the contributors. And about this question thing, this is also a very good way to discover problems. So this is something we had at the beginning. Our users were always asking the same question, which was, how do I test the modification on the library in my project? I change the component, and I want to see how it looks like on my project. Okay, the classic way or the easy way would be to create a new package and then import it, but that's quite long if you have to iterate more than once. So our first answer was you can use npm link, which is a tool made for that, which will create a symbolic link between your dependencies and the library. But we had, and they were quite happy about it, But they had other issues, like conflict between dependencies, peer dependencies that were not there, conflict between Babel versions, and so on. So we had questions and questions and questions again, until we managed to write this quite huge documentation again. So again, this is in the contribution process, we added it there. And this is the best way we know to make a link work. And since we wrote this, we had like 1 or 2 occurrences of this problem again, but we managed to reduce it as much as we could.
Okay. So now we have a package. We are showcasing it. We have a whole process as a core team to be able to take care of these libraries, of this library. But the next step, and we have a lot of developers, but the next step now that there's going to be a lot of activity on the platform is to be able to protect our developers. Why? Because there is a lot of activity. So there is going to be a lot of different conflicts of development, potentially even more bugs, because those teams are not the same. They don't always communicate. So we need to find a way to protect them. Just being a core team and answering their questions is not going to be enough. And we felt it. So let's put our shoes in the developers we are working with. They are not contributors they're not open source contributors. They're working on a website, so they're quite used usually on working on their own components, changing the API of the component, seeing the impact it has on the rest of the website, and then adapting it, and that's it. And the thing is that they had somehow the same behavior when they were contributing on our own shared library. So in this situation, of course, those 2 developers were sharing the same component. So if the first team, Project A, for instance, wanted to change the name of a property without just anticipating a little bit the impact it might have on others, it would, of course, break the next time they would push a new version, and it would break the next time that another team would update this same library. So that's what's called, of course, a breaking change. You know it, but you might not know how easy it is to really just introduce them, and we felt it. We needed to find some automatic solutions for this not to happen again. We are using Flow as a static type checker. Of course, you could do the same thing with TypeScript. And we wanted to use one capacity of Flow. We created an API file at the surface of the library, describing the whole API in itself, directly, of course, connected to all the below components. And thanks to that, the host projects, when they were reusing our packages, they were using this exact same API file in their own Flow runtime. And if someone created a breaking change in the file ahead of it, it would break in their own CI. So it was extremely convenient to anticipate bugs in production. But it was not enough. We wanted to be ahead of that at the moment where the developer is creating the breaking change for him to be able to anticipate it. We're using Danger on the projects. So Danger is a tool allowing you to define custom rules about bad patterns on your projects to be able to flag them during the continuous integration, and at the same time to display messages in your pull request on GitHub. And we used it in this specific case by checking at any line that might have changed in the API file, in the Flow API file. If a line changed, it's a big hint that might be a breaking change. So then the developer was noticed directly in his pull request to pay attention to that. Maybe he didn't want it, maybe he did want it, but at least he knows. And it, once again, helped us a lot. Further than that, we are using semantic versioning and committizen and another set of tools around that to allow the developer, now that he knows that he's creating a breaking change, to document and to document it for the next developers. So he's going to say that it's a breaking change, so he's going to create a new major version automatically, saying that it's a breaking change, and he's going to directly in his terminal put in all the information that's necessary to know to be able to adapt to the breaking change. Then the information is going to be displayed directly inside of the commit message and in the changelog generated by the tool. Next step, so now we have one library protected from breaking changes. A lot of developers, but we have only one library. and it's starting to grow. There is a lot of developers. We have 6 teams working on the project at the same time. So there is more than 50. I think there is even 100 components. It's huge. So we started to have some more issues. We needed to split. I'm going to tell you. Split the library. So let's come back to breaking changes. You have the breaking change. Once again, it's creating a new major version. There is all the teams in front of it that are going to be noticed of the breaking chain when they will want to update the package. But the problem is that the team that created this breaking chain might just have changed the API of one component over the 100. So one team is going to be affected by this because this team was using it potentially. I think, yeah, I hope 2 teams because this component shouldn't have been there if it was. So let's say 2 teams. But the rest of the teams wouldn't really care about this breaking change. They're not like concerned about this breaking change. They don't really use the components. So it's a frustration. It's a waste of time. As there is a lot of breaking changes happening over the week, and I just have to go through the changelog to understand what's happening, and it doesn't really impact me. So we needed to find a solution. We could have created one library for each component, but it would be a little bit tedious and a little bit complicated to handle. So we decided to use to split our libraries following atomic design. You might know atomic design. It's a concept from Brad Frost, which is a designer among other things. He defined how you should define your components in a way for them to be more easily composable. So you have 3 big groups. There is a little bit more. There is pages as well above organism, but we follow those 3 big groups: atoms, molecules, and organisms. If we show an example, let's say that a date picker, for instance, is an atom. It's a micro component, a presentational component. It's more in the atoms. You're usually more going to see a design system type of components. It's stateless, usually not related to any business. Then you have the molecules. So let's say you have this. It's a Navistory, something very specific to bank, composed of several atoms, our date pickers and a button, for instance. So a molecule is a little bit bigger. It's a composition of atoms. It's stateful. It's starting to be to show something related to the business and to the website you're developing. But by itself, it's not going to be useful enough. You need to compose several molecules and atoms to make an organism. An organism is going to be a fully fledged feature. This time, that's serving one purpose complete for a user. And that could be, and in our situation, it was even this big feature reused by several websites. So that's what we did. We have one library for all of our atoms. It's really our design system. We have one library for all our molecules. And we have one library per organism because the organisms are quite big. There is even a Redux store inside of them. So we prefer to split it this way. Now let's go back to our breaking changes. So if there is a breaking change on the atom, what's now useful is that, as we just displayed just ahead, you have the flow configuration, the flow file, that's going to tell you that there is a breaking change in the atom being used by the molecule. So you're going to have a warning by your CI, if you forgot about it, that there is a breaking change in your atom, and you're going to need to adapt it and to fix it. So now the developer is gonna be able to push the atom as a major and the molecule as a minor, and it's not going to impact other people, other teams. So way more people happy, way less people frustrated, and way less time wasted. But we encountered another situation. Now, let's say that we just do a little bug fix on the date picker. This bug fix is not going to change the API. So the flow file and the CI is not going to tell you that there is a change in the atom. So the developers might forget that you have to update the molecules above or the organisms that are reusing this date picker, which is an issue, which is a problem because it's a bug fix. So it's a shame. We needed to find another automatic solution. So we decided to use Lerna, which is another library, a monorepository manager, that allowed us to automatize and solve this problem. So this time, Lerna was capable of seeing the connections between the components and automatically bump the parent to a minor version and bump the parent of the parent to a minor version as well. And there, our monorepository of several libraries was working, and we didn't have we didn't have any more issues.
So in this situation, we have a library of packages that you can share, that you can showcase with Storybook. But there is still one problem that you have to address, is the problem of performance. I'm guessing that you've all been already on internet with your phone, sometimes in a bad network situation. And even if websites are not slow just because of JavaScript, JavaScript is still sometimes one of the biggest culprits. And the problem we have with our packages so far is that they're heavy. Here is an explanation of why. So let's imagine I created this small library with only 2 components in it. One heavy, like super heavy with a lot of images and whatever you can imagine, and the light one. And then I create 2 applications, exactly the same applications, but one with a heavy component and one with a light component. And my intuition tells me that the second one should be lighter. And actually it's not at all. Because if you remember, at the beginning, I told you something about UMD, about building your package as a UMD so that it's compatible with different bundlers and with the browsers. The thing is, UMD is basically a very big function because it has to handle the different situations. And this function will return all your components. And because of this, when you're on the application side, the bundler doesn't know what you are using, what you're not using. So the bundler will just take everything and put it in the application as your dependencies. And the application with the light component will actually have the heavy one within, which is why those are the same weight in the end, although it's not what you want. So tomorrow, if you're using this with your phone, well, you will download the heavy component without even using it. And the page will be slow to download and you'll be angry. So a way to avoid this is actually to use the ES6 standard of import and export, which is, I think, one of the things you use every day when you code. So a simple solution would be to directly export your sources. You remember this main property? Instead of exporting the bundle file, just export your sources. This would work, but this is actually a bad solution for 2 reasons. The first one, well, not all bundlers are able to support this import-export thing. So for example, Browserify does not. And then, if you have like super fancy JavaScript features and that you need a very specific Babel configuration to make it work, now your users have to have it. So they have to have the same Babel configuration as you and the same Webpack configuration. So you are enforcing your configuration on your user side, which means basically you would have, as application developers, to think, okay, I'm using this library, so I have to put this in Babel and this in Webpack. So this is boring. This is not something you want. So we tried, so I told you about Babel. We could also transpile the code with Babel and export that. This is actually what we tried the first time. But it becomes very hard to handle images and basically assets. So what we recommend today is to use Rollup. This is something we're trying right now, and we have very promising results about this. So this is a bundler that is able to actually handle ESM module and all stuff. And this is the configuration that is working for us today. So what you can maybe see at the end of the room is that I have 2 different configurations. The first one above will output something with the import-export stuff. And the second one will export this UMD file that works for everyone. Which means that I have now 2 files that I export, and I can use the main property of the package.json and another one code module. So now, every bundler, like Webpack for instance, which is able to understand this import-export standard, will use the module entry point. This will allow Webpack to perform tree shaking and remove the component that you don't use. And for those who cannot, like Browserify, or if you want to use this directly in a script tag, this will use the main entry point, and then this will work as well in different situations. So to summarize, we told you here what we learned when we tried to create our library. And the bottom line is, use the atomic design and think about different packages, split your components in different units to reduce the impact of breaking changes. Decide how you want to distribute your package and think about the performance. So when you create your packages, think about performance and how to distribute them. We advise you to use Storybook to showcase, but if you have another solution, it's fine too, but Storybook is actually a good way. Make extra effort to encourage contribution. This is the best way for your library to grow. And if you want to conquer the world at the end, this is the way to go. And when you will have a lot of contributors, you will have to make sure they're protected from each other so that they can work in the best possible environment. And we have a last thing for you.
We wanted and we decided to share our project as a fully functional project itself. You can launch it inside, so you're going to be able to see all the configuration, all the tips we gave you right there in the code, and to dig in. There is much more than that. So you can see how we decided to create themes with our components as well. We added the tips on how and is it worth it to have such a project for your company, because it costs as well to manage such a it gets complicated at some point. So we did analyze the value of such a project, and there is some more tips that you can find on the repository if you're interested and you want to dig in. And if you would like to participate and improve it would be amazing as well. That's it. Thank you.
Thank you very much.